Hello and welcome to Sepasok Academy, the Intersects on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. So if you are new in this channel, I will invite you to subscribe to the channel to not miss any of our videos uploaded. So in this video, we are looking at June 2019 advanced level mathematics with statistics paper 2, because remind that on 2019 statistics and mechanics students hold paper 2 differently. That is different mechanics and different paper 2 but on the same day. So the question is on vector. The question reads: the vector equation of two lines L1 and L2 are given by what you have on screen there, where A, lambda and mu are real constants. Given that L1 and L2 intersect, find A, the value of A, B, the position vector of the point of intersection of L1 and L2, C, the cosine of the acute angle between L1 and L2. So dive directly to the solution. A, the value of A. First, we record our word. R is equal to xi plus yj plus zk. That's the general Cartesian form of I. So we write the parametric equation. So to write the parametric equation of I, we are seeing here that they said R is equal to xi plus yj plus zk. So you just equate coefficients. So x, the coefficient will be I, and then y, the coefficient will be j, and then z, the coefficient will be k. So we just replace like that. So x1 is equals to 1. This is 1 here, the coefficient of I, plus another coefficient of I, which is lambda, and so forth and so on and so forth. So the next, we equate x1 to x2. That is, we have 1 plus lambda to be equals to 2 plus 2 mu, which implies that we send 2 mu the other side, we are going to have lambda minus 2 mu, and we send 1 the other side, we have 2 minus 1, which is 1. We call it equation 1. And then we equate another one, z1 to z2. z1 equals to z2, we are going to have 3 plus lambda is equals to 6 plus 3 mu, which implies that lambda minus 3 mu, because we send 3 mu the other side, we have, and we send 3 the other side here, we have lambda minus 3 mu is equals to 3, and we call it equation 2. Now, after having your equation 1 and equation 2, you now find for the value of lambda and mu. The idea is to find the value of lambda and mu. So to find the value of lambda and mu, I consider equation 1 minus equation 2. I will get that lambda minus lambda is 0, and then we'll have negative lambda, that is negative 2 mu, minus 3 mu, which is positive 3 mu, is equals to 1 minus 3, which is negative 2. So you imply that our mu is equals to negative 2, because negative 2 mu plus mu is mu. So mu is equals to negative 2. Now from there, we now replace the value of mu in equation 1. Replacing the value of mu in equation 1, I'll get lambda plus 4, because negative 2 times 2, negative 2 times negative 2 is 4, will be equals to 1. We imply that lambda is equals to minus 3. So the values of lambda and mu are just means that are not the goal of the question. The goal is to find the value of A. So we say that since the lines intersect, it means that y1 is also equals to y2, which will imply that negative 1 plus 3, because lambda is minus 3, is equals to A minus 2, because mu is negative 2. So you imply that my A is equals to 4, because minus 1 plus 3 is 2. Then when 2 goes the other side, becomes 4. So A is equals to 4. Now the B part of the question, we are finding the position vector of the point of intersection. So to find the position vector of the point of intersection, we either replace the value of lambda in L1 or the value of mu in L2. All will give the same answer. So I will prefer to replace the value of lambda in L1. Now the idea here is what? I replace the value of lambda in L1 because replacing the value of mu in L2, if you are not sure your value of A, it will be difficult, because it will not be difficult, but it will reduce your chances to have all the marks, or to have most of the marks, because when you replace the value of mu in L2, your value of A might be wrong. So replace the value of lambda to minimize the error, because there it is already there is no unknown to find on L1. So I replace the value of lambda in L1. I will get that the point of intersection will be R. Now R is equals to I minus 3j plus 3k minus 3, because lambda is minus 3, into I minus j plus k. There. So it means that my R will be I minus j minus 3k. Open out the bracket with 3, we have minus 3i plus 3j plus 3k minus 3k. So it means that our R will be equals to I minus 3 I is minus 2i. Negative j plus 3j is 2j, and then 3k minus 3k is 0. So it means that the position vector of the point of intersection is negative 2i plus 2j. Okay, there. So if you replace the value of mu in L2, you are still going to get this point to prove that the line actually intersects at a particular point of intersection, which is negative 2i plus 2j. So if you enjoy what you are seeing here, I'll invite you to like the video first. Like the video. So the C part of the question, they said the cosine of the acute angle between L1 and L2. To find the cosine of the acute angle between L1 and L2 is by formula, which is cos theta equals to d1 dot d2 over the magnitude of d1 times the magnitude of d2. d1 here signifies the direction vector of L1 and d2 is the direction vector of L2. And the direction vector are always carried by the constants lambda and mu. So it means that my d1 dot d2 will be the direction vector of d1, that is it here. I've already represent it here, that is I minus j plus k, and then the direction vector of line 2 is 2i plus j plus 3k. You can just go on the first page to see the direction vector of L2. Now dot product, in dot product you have to record that I dot I is equals to j dot j, which is equals to k dot k, which is equals to 1. It means that if you do the dot product of I dot j is 0, that the dot product of I dot k is 0, and the dot product of j dot k is 0. So it means that my dot product here will have I dot 2i, which is 2, negative j plus j is negative 1, that is dot j is negative 1, k dot 3k is 3. So it means that d1 dot d2 is equals to 4. Now d1, the absolute value of d1, that is, or the magnitude of d1, is simply 1 plus 1 plus 1. Now don't be surprised that I'm putting 1 here, because even if I put negative 1, it will still be positive because it's inside the square. So it means that the magnitude of d1 is root 3 there. So the magnitude of d2 now, the same formula. So here I'll have 2 square plus 1 square plus 3 square. When you calculate it appropriately, you have that is will be equals to the square root of 14, because here you have 4 plus 1 5 plus 9 14. So we'll replace it on our formula. We have that cos theta will be 4 all over the square root of 3 times 41, and which will imply that cos theta is 4 all over the square root of 42, because it said find the cosine of the acute angle, not the acute angle itself, the cosine of the acute angle. So this is the cosine of the acute angle here. So guys, we have come to the end of this video, and if the video was interesting to you, I'll invite you to like, subscribe, and comment the video, and also share the video to help your friends attain academic excellence. And not forgetting that in science, consistency is the key.